have is we have DFT sum of a smaller summation on each half of the size of the original. So we can repeat this process each of these even and odd indent summation into their own even and odd indent summation. So every time we split the summation, we have a number of operations to calculate DFT. We generally use recursive method to program the FFT algorithm. This is not the most space speed efficient way to program the FFT, but it is the easiest way to put together one that works. So, so the function recursive split the sample all the way until we have one sample left and then work backward through each level combining the values until we arrive at our frequency range. So this is the basically the way FFT works and the way FFT actually more faster than DFT structure. So as I have told you that butterfly unit is the main processing unit of FFT. Okay, so it is the building block of FFT, and it consumes the most of the power of FFT structure. So this paper considers simple butterfly structure as shown in this figure. Okay, so what we are doing is W is the total factor, B is the input, A is the input, and both are the complex in nature, and both considers 32-bit word length as input, and we are the W also was of 32-bit, but and the B and W is get multiplied, and then A from A it gets subtracted, and this is the basic equations in the with complex values, and this is the basic output that these are the basic output that we are getting after the calculation. So these are the basic equation of butterfly unit, and and the output we are getting. So we have to get a better understanding of these to get understand how I will design the 4.8 structure. So these are the equations that we have to calculate. I have taken the real and imaginary part every time and calculate it. Okay, so basically butterfly unit is based on the called tensor linkage lemma, and this is the basic nature of the tensor linkage lemma, that total factor is symmetric in nature. So this is how it works, and we are actually calculating it by equations. Okay. So when I have implemented that butterfly structure, this is the basic RTL view of that particular butterfly structure that I have mentioned there. Here it is. Right? So now come to my main motto to give you the understanding of 4.8 structure. So 4-point transform is reduced, as I said you that it reduces the bigger structure into a smaller unit until we get the smallest point. So what we are doing is we are reducing 4-point transform is reduced up to two-point transforms both for odd and even elements. Okay, so the odd one will be multiplied by W4K, and it can be presented as two level of butterfly. We can implement 4-point using 2-point transform. Each 4-point reduced to a structure consists of 4 butterfly, each having real and imaginary part. Each butterfly has 4 multipliers, 3 adders and 3 subtractors. An efficient implementation of this unit plays a very critical role in design. As I said you that it has 4 multipliers, 3 adder and 3 subtractor. So better adder and better multiplier design can enhance the overall structure of that particular butterfly, or you can say FFT structure. Okay, so this is the 4-point structure, and here we see something that is very important, that we are not giving the input in the real order. We are giving I0, then I2, then I1, and then I3, so that we can save the memory. So you will understand in the later slide that why we are using it like that, and we are getting output in the better order. Okay, so we have a total factor like W20, W40, and W41 for the calculation. So actually here it contains the 4 butterflies, and each butterfly consisting multipliers, adder and subtractor, as I said earlier. So computation cost of 4.22 FFT requires first to analyze butterfly structure, which contains 2 multiplication and 2 addition. Therefore each butterfly unit costs 2 complex operations, and this is the basic flow diagram of our FFT structure, having 2 stages, and each stage has inward 2 butterflies, and RTL view of 4.8 is shown in the next slide. Okay, so here you can see that we are getting the 4 butterflies, and each butterfly has a complex addition and subtraction. So